For today's video, I'm going to show you how to make a part using the Harig V-block grinding fixture, typically referred to as a whirligig. Now, what this is going to allow me to do is to take a part and make a part that's going to look like this. This is a project that's part of our tool&die program. Gets them used to grinding this on a this grinding fixture, which allows you to do a lot of different operations. So basically, you're going to take a part from this point right here, and you're going to go about turning it into the final product. So as you go through this right here, you take it to the milling machine, you'll cut those down, and then we'll cut these sections down, and then you'll take it over the grinder and you'll grind it. And that's going to allow you to go about creating this shape right here. These are very versatile fixture, but it's also a very complicated to use and difficult to set up fixture.
A part like this blank could be made on a manual lathe. Granted, you wouldn't be able to have this smooth blended out radiuses quite as easily as you can do it on a CNC. Well, to give our students some more CNC exposure, we do this on a Mazak lathe that we have using Mazatron. So use the conversational programming to go about creating the profile, which allows you then to generate the shape of the part and then build a tool path off the shape of the part. So as you go to verify this, you'll see that basically it's going to go through and show the different steps of the operation that are being done to go about machining the part. And now that my part is complete, it's time to take over the milling machine and further rough out the shape and preparing this for going onto the grinding fixture to go about grinding the profile and the shape that this piece has to be.
Okay, the next thing I want to do with this right here is go ahead and get it clamped into the grind-all fixture. I've commonly heard these referred to as a whirligig by a lot of old tool makers I've been around, but their official name is a grind-all fixture. This is a Harig Grind-All fixture. Number one, it's got a 3-inch center heights in it. It's an extremely versatile piece. Now when I'm putting this in there, one thing I got to make sure of is that I have my piece orientated where This is roughly straight up and down to begin with. I'm going to need that because I'm going to have to offset it coming down this way right here to be able to do the radiuses on the edge, which this piece is going to have. So to initially do it, I want to make sure this is roughly in line. I can trim it up when I get a little time, but right now I want to make sure it's roughly in line.
After clamping this in my grind-all fixture, I need to go about loosening this clamp screw on the bottom, which is going to allow the V to move up and down to go about centering my workpiece up. There is an additional clamp screw on the side that's going to help me correct for the runout I have. As you can see, I have some runout here. So next I'm going to take my indicator and I'm going to zero it out on the side. I usually turn it 90 degrees opposed to the V to indicate this in. Typically the side to side is pretty good on these. I've ran some older ones that had a little bit more variance. I'm going to rotate around and move my fixture back and forth to find my high spot. In this case it's almost 60 thousandths. So I'm going to go about adjusting this back to 0 because I zeroed off on the side. So I'm going to put my Allen wrench into the screw on the side and I'm going to go about turning it back towards 0. Once I get back to 0, I'm going to basically move back and forth, make sure I'm at my high spot again. In this case I was. And then I'm going to rotate it back around and see how it looks the rest of the way after clamping the screw down. Now sometimes when you clamp the screw down it's going to move a little bit. In this case it did. It moved about 5 thousandths, so I did have to go back and do some additional indication on it. So when I verify here, you'll see that I have basically about 5 thousandths out now. Pull the pin out to allow me to rotate it. I rotate it around and I have basically about 10 thousandths total run out. Now depending upon what you're doing, that may be good enough. Once again, if this has features that are not going to be ground, I'd want to make sure that I indicated it in. And now I did a little bit of indication off camera. I basically just did one more adjustment on it. And basically checking my high spots now to make sure it is true, and I have tightened the screw down and everything is running true. So this one right here is ready to go. It's going to allow me to move on to my next step of this right here, which is going to involve locking in position at my 90-degree mark. I'm going to go about indicating this flat in so I can ground this flat. Once again, how much time I spend with this indication will depend upon if this is a finished surface that's not going to be touched, or a surface that's going to be machined and ground. In this case, I've got about 60 thousandths run out, so I'm going to basically zero it out there. I'm going to move back across, find my high spot, and it's about, right about 60 thousandths run out. So what I'm going to do right now is I'm going to slightly loosen this clamp screw on the back of it right here. And after loosening that clamp screw, I'm going to take and put myself an adjustable wrench on it, and I'm going to turn this slightly. By turning this slightly, that's going to allow me to indicate it in and get it to where this will be within the amount of grind stock that I have. Once again, this could be 2 thousandths out, 3 thousandths out, 10 thousandths out, depending on how much grind stock can still be acceptable. But in this case, I want to get it pretty close. So what I'm going to do is move it back half my amount that is out. Went a little bit too far, so I'm coming back to it, back to my 30 thousandths. I'm going to run back across, re-zero on the low side, move over to the high side. I usually work back to my high side here. See how close I am now, and I'm about 20 thousandths this time. So I kind of rinse, wash, and repeat the process. Go back, make an adjustment while it's on my high side, and bring it back to 10 thousandths mark, and then repeat the adjustment, repeat the indication one more time. And if it checks true enough for what I'm doing, I'm going to go in and lock it in. Now in this case, I decided to do a little bit extra to try to see if I could get it better than the 2.5 thousandths I was there. I have 10 thousandths grind stock per side on this piece, so it would have cleaned up, but in this case I wanted to try to get a little bit closer just to show y'all the process. So I'm going to move it back a little bit, check my adjustment one more time, and then go about clamping it in place snug in the clamp the rest of the way, and I should be good to go. Okay, one thing to remember this right here. When you have one of these, you do have to think about what your part looks like before you go to set your piece up. If I had turned my rectangle the other direction, I would not be able to offset it the way I need to. Because this is in line with my V, I have the ability to offset this down or up to go about getting my center line correct to go about grinding my radius. And that'll be another step that we'll do here in just a few minutes.
Okay, next step of this right here is we're going to need to go about grinding it. A couple things I need to set up here. One, I want to make sure this is squared to the machine. I can do this two ways. In this case, I took a 1-2-3 block and I put it up against here when I went to tighten this down. That works pretty well for that. Another way I could do is do a 1-2-3 block up in this area right here, or some parallels in this area right here. Both of those methods would work, but for either one of those methods to work, the machine would have to be indicated in this case. I know that we indicated this surface right here as we went to do so. Another thing I wanted to do, I wanted to make sure my center line was right a little bit on the right side of the wheel here. The reason for that there is I'm using a stop here, and the stop is going to allow me to move over this way right here without it grinding the parts. I can actually move over and check my diameter a lot easier than I could if I was trying to work off of the dead center, or I was working over here on the left side. So I want to make sure I get that there. So what I would do next is bring this over. I brought it down and touched off. Get up against the stop. And I go about rotating this right here as I rotate across the handle here to get the feet in. That's going to allow me to grind my diameter. That's my first step on this project. When I come up here close and I get close to that shoulder, I am going to mark my 0 on the cross feet, and keep working back to that 0 point. At this point, I've taken several passes on this right here. I'll go about miking it. After miking it, I'll be able to get a dimension and see where I'm at. In this case, I'm going for 750 thousandths. So in this case right here, I am currently at 755 thousandths. There, so I got 2.5 more thousandths to take. I'm going to take 2.5 thousandths off because this right here reads off the radius. It's like an older lathe that reads off the radius. Taking an additional 2 thousandths off now, and I'm at 751, so I'm 1 thousandth away from where I'm going for. So I need to get that additional thousandths off there. So once again, just because this machine, the way it's grinding, it's going to read off the radius. I'm going to take off that thousandth by taking off a 1/2 thousandth. I've done some additional passes on this, and I am at my 750. So I'm ready to go on my next step. My next step on this right here is going to involve grinding these surfaces right here to be a rectangle. So I'm going to do that by locking this in position using the graduation sphere and the pin here. Now, because my part has a 1/4 inch radius at this point right here, I need to do something to make sure I get that radius under my piece. So what I'm going to do is I'm going to use something called a form dresser. This is a form dresser right here. It is a very versatile tool that's used in the tool and die industry a lot. And anywhere you're doing grinding, it's going to allow you to be able to swing radiuses and cut angles. You can swing a radius to an angle, to another angle, to a straight section. There's a lot you can do in one of these. Well, first off, you have to know how to actually set one of these up for measurements. And what I'm going to do is I'm going to take a reading over the diamond here. Take a mic reading over the diamond. And that's going to allow me to know how to set my radius up.
Okay, I've used my 2 to 3 micrometer to pull a reading on my diamond. I'm pulling it from the tip of the diamond to the back of the plate here. Now, I have a reading here of about 2.4385. Now, my blueprint, I have a fractional tolerance there, so I'm not going to worry about that 0.5 and just use a 2.438 for my reading. Now, what I'd want to do now is I need to figure out how to use this reading to go about setting it up. Now, there's an alternate way to do this. I could take and subtract the pin diameters from which are 3/8 from my diamond mic reading, and then work on the inside of a gauge block stack. That works good, but in my experience, I already have a micrometer. Now, micrometer will allow me to do this and set this up, so why not just use a micrometer that I have in my hand to go about setting it up? So what I'm going to do right now to go about grinding this convex radius on my part is to add my radius to the diamond mic reading. So I adjust my micrometer to reflect that reading. If I was trying to do a female radius, I would go about subtracting my radius, and that would be for the. Okay, now I've got this clamp loose, and this is going to allow me to move this back and forth. Basically, I can tighten the clamp back up. And what I want to do here is put my mic up here and be able to get it to where this will meet. A couple more things I want to do. I want to make sure my grinding chuck is clean before I put my form dresser up here. And I need to make sure and get my center heights of my diamond to match up with the center of the spindle. A lot of times I can bring it around and actually line these two up physically. That's going to allow me to go about grinding the correct radius. If I'm too high or too low, it's going to affect the radius that I'm grinding. After setting that up, I then can go about feeding in to go about dressing my radius. One thing I have to do is make sure that my grinder is up against a hard stop. That's going to allow me to control my locations and also be able to move it out of the way and do it there. So what I do is set stops in the micrometer to allow me to do it. I have a fine adjustment here that allows me to move in. I move in until I touch the grinding wheel surface. Then as I swing around, I use my cross feed to move in and control my depth of cut to go about truing this up to match up to what I'm trying to do. It's a series of going back and forth with it, stepping in until I get it there. Once I get it to where there, I then transition to using this handle on the back of it to go about relieving the surfaces there. That will grind an angle onto the surface there at a slight angle, and then I can use my cross feed to go about stepping over this right here to go about truing up my surface this way. This allows me to have a radius that's blended out with two surfaces, so I can grind to a shoulder and grind a effective radius on the part. To go about grinding this face here, I may have to step in and move it a little bit with my micrometer stop there. So I can loosen the clamp screws there and adjust that to allow me to step over. Keep a little pressure on it to keep up against the hard stop, move back and forth until I get a true flat surface. After grinding a little bit on this right here, using my radius dress wheel, I'm going to go about miking it. I'm going for 250 thousandths here. I'm checking at 255 right there. So what I'm going to do is I'm going to move down. Because I'm grinding off both sides, I need to move down, factoring this in like I'm working off a radius on a part. So I'm going to go about stepping down a thousandths in this case and go about grinding back and forth to true up the surface and get the surface.
Now, for my next step with this, there's a little saying you had to remember way back to the beginning of this. That if you didn't set this up with this feature right here in line with the V, you're going to run into issues. So what I want to do right now is I want to set this up so that I can shift my center point, my radius. And how I can do that there is swing this around over here till it's parallel, and I want to take my indicator and pull my plunger up, roll my indicator under it, and I want to zero it out. I'm good there. So that's actually a good zero there. So I want to zero that out so that whenever I shift this around to the other side, pull my plunger out again, rotate it around this way, I'm going to shift it out to where this is a blended out radius. So now this right here will be up higher by about 125 thousandths. And I'm going to shift that down back to my zero. How I'm going to do that there is I'm going to loosen the clamp screw right here and take the adjustment screw on the other side and bring it down. At this moment I have shifted it around, I've loosened my clamp screw right here, I have the Allen wrench in here. This Allen wrench in here is going to allow me to braid this down. I want to braid this down to 0. So keep making the adjustment further and further. Next step I want to do is I want to snug this up. Make sure that's good. Clamp is good here. Take both Allen wrenches off. 0 right here. Now when I pull this out here, the pin out, rotate this 180 degrees, I still should be 0. Okay, so now I have 0 this out of the back here, got it at my 90-degree mark, and I'm going to braid this up here and bring my indicator tip down and make contact. You see I'm a little bit off at 0. I expect it to be a little bit off. That's not unheard of, so what I would do here is re-zero there again on this surface here, rotate back around to the other surface and just repeat the process. And I'd keep doing this until I got it to where it read consistent 0 between the two sides. So ultimately I'm going for having it be 0 on this surface and 0 on the other surface over here also. Okay, now that I have this set up to grind this radius, my rotation's been shifted down, I need to go about setting up a stop. To set up a stop, I'm going to push this pin right here out. That's going to allow me to have a hard stop here to bump against. I need to set up a second one that I will set up at my 90-degree mark, which I'll lock in place right here, and I'll loosen these two set screws. That's going to allow me to slide this over. Now I got these pins in place, and it's set up to my 90-degree marks. It'll allow me to rotate it around 90 degrees opposed, which will allow me to grind this blended out radius on the piece. Okay, now one thing on this right here is once I get myself touched off, I need to make sure I have spin my part centered up under my wheel. It's going to allow me to be able to rock this back and forth and grind my radius on it. I'm going to slowly step my way down as I step over. That's going to allow me to be able to grind this blended radius on the piece. Not exactly the most efficient process. To take probably about 5 thousandths off a pass relatively easily. I want to keep an eye out for my 0 point where I want to stop my shoulder at. Stop my 0. Back myself up. Feed back down a few thousandths. Feed back across again. As you saw with the sparks there's a weird kind of transition that occurs when you get to this one area that you've not really machined. And that's what I hit there with that transitional period. And what I'm going to do is I grind this, I'm going to see the little line in the center get smaller and smaller. Go back across. Feed down again. Keep working your way down until you begin to see more and more of a radius form as you go. As that line gets, the center gets smaller, I'm going to be more careful about how I handle this. When I get close, I'm going to touch off of the flats before I do anything else. Feed back across again. Once again, I'm grinding this radius on my piece. As I'm grinding this radius, one thing I'm going to do a lot of times to get an idea of where I'm at is I'm going to put some dicom on the top surface here. That dicom is going to allow me to be able to see that line as I go. That line will indicate when I'm getting pretty close to being to the size I need to be. Now that I'm close, I'm going to start doing a little different on the step down. I'll start feeding down a couple of 10 thousandths at a time. Keeping an eye out for that line, but also keep an eye out for sparkings when I get to the extremes of movement. There you go. You feel a hit there. That's a sign. That's about as far as I want to go here. I'm going to back it up about 2 10,000ths of an inch. And that's going to be my point. You see how it's hitting right here? Like come over here is wanting to spark. A little something you can do if that's a problem is I've taken a piece of paper and wrapped it around here, or taken a piece of tape and wrapped it around here to give this just a little bit of cushion. A little bit of cushion a lot of times will prevent that from sparking there where it hits this hard stop right here. Look at I'm blending out this radius here. This piece will be. Okay, now you can see how I have the complete ground radius here. I need to ground the angle. To ground the angle, I need to do a couple things. I need to set it here. Now I have graduations here. This right here is graduated and got indexes every 15 degrees. That works well. It also has a lock. I can bring it around to where I want it to be and lock it down right here. And that'll work fine too. But there's a better way to do this that's going to actually give me an accurate read. Okay, since this is normally a student project for us, we have several different angles and radiuses. I'm going to do a 17-degree one right here, which means I'll go to the 15-degree spacing, and then you need to go an additional 2 degrees. Well, how to do this is I'm going to take my sine of my angle, which would be 2 degrees in this situation, and multiply that by the constant. And that'll give me the amount of gauge block stack I need to set mine to the 17-degree angle. Okay, here's where I have 2 choices. I can set my grind-all fixture to 15 degrees and then put a spacer and take up the 2 degrees extra I need, or I can set it at 0 and do 17 degrees. This right here is ends up being 0.073, which we'll have a gauge pin for, but I'll have a gauge block stack for. This right here ends up being 0.614, which I could do that with gauge blocks, but once again, it's a pretty good distance to try to space this out. In this case, I'm going to use the gauge pins that we have and go with a 0.073 spacer. Now when you're setting this up, you want to make sure that you've got this set right. You want to make sure you have your piece turned right. I had to physically take the print and take a look at how my part was going to look and then basically figure out how to turn it to get there. That's a good way to kind of keep yourself from getting confused about what you're trying to do. Now I'm bringing this to my 15 degrees back here on the back with my stops up against it right here. I tighten these down because these are going to stay in position. So tighten these 2 screws down on this right here to lock this into position. Then I pull my pin out over here. I pull my pin out over here, it's going to allow me to rotate this around. I take my 73 thousandths gauge pin, I'm going to put it into here, and I'm going to go ahead and unlock this one right here. Bring it over till it makes contact with the other side of the pin to help me lock this in position. Okay, once I get this in position right here, I'm going to lock this on the back. Here. So on the back. And the last step of this I would do is I go about grinding my angle onto it. What I would do to grind my angle is I'm going to touch off here, zero out my down feed dial, and then plunge down the amount I need to in a series of passes going across here. One little thing about the math involved in this right here, this is what my piece looks like right here. I have a 17-degree angle. I have 40 thousandths here. It did not give me this dimension. So I have to find that dimension here. Well, what I have here is my side adjacent and my side opposite. So I'll use the tangent of the angle is equal to the opposite over adjacent. I modify it to solve for the adjacent, plug my values in there, and I end up getting 0.13. Now, then I need to draw myself a line from this corner here down to this other side here to create myself a right triangle that gives me a depth I can feed down. This is going to involve my hypotenuse and my opposite. So I use the sine equals the sine of the angle equals the opposite over hypotenuse. Modify that and solve for it, I get 0.038. So that's going to be my down feed, 0.038. So what I want to do next is bring my grinding wheel over my part and then start feeding down gradually. As I feed down gradually, I'm looking for sparks, I'm listening for a sound change. There we go, that's it. So then I would zero out my down feed dial. And what I'm going to do is I'm going to feed down in a series of passes along this. You know, how much I take off per pass, 4 thousandths will work fine, 8 thousandths would work okay. It's a pretty small piece, so I wouldn't go too aggressive with it. I'm going to do about 4 thousandths a pass here. I'm going to step myself over until I get to this corner. Again, I'm going to my blend out point here. Be careful not to gouge anything. That'll become more critical as I go deeper with this. And after all the grinding and all the different processes, here's my finished product. Here, you can see using the 1/4 inch radius caused it to blend out pretty nicely into the corners here. Transitions nicely with that. It's a little tricky and interesting trying to get all these different angles to try to blend out, but they did a good job with this right here. By the way, one thing I don't think I mentioned there is right here, I did use zero out my cross feed there so I knew where to stop. Now, this piece right here is a unique piece, but the grind-all fixture allows you to do pieces like this right here.
Once again, I am Derrick Hogan with North Georgia Technical College in the CNC Technology, Precision Machining, and tool&die programs. We are working with Practical Machinists to collaborate to make some educational content videos. If there's anything you would like to see, leave a comment in the comments below with any ideas that you may have. And also don't forget to like and subscribe for additional videos.